Hello, this is Systems of Linear Equations and Inequalities, Solving Linear Systems by Graphing, Example 3. And this is the system we're going to try to solve graphically. And so I have to graph this first equation and then graph the second equation. So looking at the first equation, a table of values works out pretty good. See, if y is 0, then x is 2. See, if y is 0, this term disappears, so I end up with 3x equals 6, and x equals 2. So if y is 0, x is 2, so I have the point 2 comma 0. And if x is 0, then y is negative 3. See, if x is 0, then I'd have negative 2y equals 6, and when you divide both sides by negative 2, you end up with y equals negative 3. So here I have the point 0 comma negative 3. So we can get those points on here, and that's 2 comma 0 is right there. 0 comma negative 3 is right there. And from this you can see you go down, it goes down 3 and to the right 2. See, down 3 and to the right 2. See? Or up 3 and to the left 2. See, that'll give you some more points, and it makes your line that much more accurate. Now we'll do the same thing for the other one. It looks, see, 12 is divisible by 4. It's also divisible by 6. So if I let y be 0, if I let y be 0, then x is going to be 2. So I said y is 0, x is 2. Okay, because I'd have 6x equals 12, so x equals 2. So if I let x be 0, then I'd have negative 4y equals 12, and y would be equal to negative 3. So that's 0 comma negative 3. Well, see, that should sound familiar. We've got the point 2 comma 0 and 0 comma negative 3. So these two lines are really the same line. And if you look closely here, if I multiply the first equation by 2, you end up with the second equation. And likewise, if you divide the second equation by 2, you get the first equation. So this solution has infinite, we say infinite many solutions, because that's really both lines. So both lines have all of their points agreeing, so it's infinite many solutions. So this is B. This is the second system. And the first equation is exactly the same. So we've already graphed the first equation. Let's just graph the second equation. 3x minus 2y equals 3. And you know, we could get 1 point here. If y equals 0, x is 1. I think I'm going to change this into slope-intercept form. So I'll start out with minus 2y equals minus 3x plus, I'm sorry, that's not right. That was minus 2y equals minus 3x plus 3. And now when I divide both sides by -2, I get y equals 3/2 x minus 3/2. Okay, it's not too pretty, but I think we can do this. The y-intercept is -3/2. So -3/2 is -1.5 right there. And the slope is 3/2. So I go up 3, 1, 2, 3, and to the right 2. Up 3, 1, 2, 3, and to the right 2. Up 3, and to the right 2. So this line looks to be parallel to my first line. Yeah, I get this line going here. So these lines never meet, therefore they have no solution. So for my second line, I figured out that the slope was 3/2. Now this first line, it's looking like the same thing. See, this first line, I would have -2y equals -3x plus 6, or y equals 3/2 x minus 2. So, I'm sorry, minus 3. So the y-intercept is just -3, and the slopes are both the same. And when the slopes are both the same, that means they are parallel lines. So the solution here is that they have no solution.